In the last few videos, we've been going into detail with rep ranges. We've evaluated if 1 rep max training can be effective for building muscle, if reps between 2 and 4 can maximize hypertrophy, and what load may be too light to maximize hypertrophy. I've created a rep range playlist from where you can find these videos. In this video, we'll explore if performing different rep ranges in your training program can help build more muscle compared to using only 1 rep range. Theoretically, different rep ranges could target different muscle fibers. Muscles are generally made up of slow twitch and fast twitch fibers. Given slow twitch muscle fibers are highly resistant to fatigue and produce low amounts of power, it suggests that higher repetitions will grow these fibers more than lower repetitions. Conversely, given fast twitch muscle fibers are less fatigue resistant but produce high amounts of power, lower repetitions will grow these fibers more than higher repetitions. However, when repetitions are performed too, or very close to failure, the point at which you can't perform any more repetitions, the evidence does not support this. A meta-analysis by combined the results of 5 studies looking at this area. In these 5 studies, the higher repetition groups used loads ranging from 30% to 50% of their 1 rep max on an exercise, resulting in around 20 to 40 repetitions to failure each set. The lower repetition groups used loads ranging from 75% to 90% of their 1 rep max on an exercise, resulting in around 3 to 10 repetitions to failure each set. Combining the results of the 5 studies, growth of slow twitch muscle fibers was similar between the higher repetition and lower repetition groups. Likewise, growth of fast twitch muscle fibers was similar between the higher repetition and lower repetition groups. Now, in this meta-analysis, the 95% confidence intervals were wide, essentially meaning we should approach these results with some caution. More research in the future will still be helpful. Nevertheless, the idea that higher and lower reps do a similar job at growing slow twitch and fast twitch muscle fibers, provided those reps are equal to or very close to failure, would make sense. Muscle fibers are recruited in a progressive sequence. During low effort tasks, slow twitch muscle fibers are recruited, but as your effort increases, faster twitch muscle fibers are gradually recruited. When using heavier loads, and therefore lower repetitions, many slow twitch and fast twitch fibers are going to be initially recruited, as your effort is high straight away. As you near failure, more fast twitch fibers are probably recruited to some degree as well. When using lighter loads, and therefore higher repetitions, the reps are going to be fairly low effort initially, but as you continue and get closer and closer to failure, your effort increases. As a result, research indicates you ultimately end up with many slow twitch and fast twitch muscle fibers recruited, probably similar to what you achieve with heavier loads. So, the current evidence leans towards the idea that higher or lower repetitions do not stimulate different muscle fibers. However, another potential reason behind why you may want to use different rep ranges relates to the activation of proteins. At the cellular level, muscle protein synthesis, so the creation of the proteins that make our muscles bigger, can be traced back to the interaction of proteins in a chain-like reaction. Lifting weights kicks off this interaction of proteins. Due to the differences in metabolic and mechanical stress between different rep ranges, they could activate different proteins. Therefore, using different rep ranges could be beneficial. Some research has indeed found that low and high reps result in the activation of different proteins. However, there is also research finding this not to be the case, so it's not completely clear. Nonetheless, let us now move on to the actual research exploring if using different rep ranges builds more muscle versus using only 1 rep range. Schoenfeld and colleagues split 19 men with an average of 4.5 years of training experience into a constant or varied group. Both groups trained 3 times per week on non-consecutive days for 8 weeks. Each session, they trained the bench press, overhead press, lat pull down, cable row, back squat, leg press, and leg extension for 3 sets each and 2 minutes of rest between sets. The constant group, for each exercise, used a load that allowed them to perform 8 to 12 reps to failure each set. The varied group, on day 1 of each week, used a load allowing them to perform 2 to 4 reps to failure each exercise set. On day 2 of each week, a load allowing them to perform 8 to 12 reps to failure each exercise set. And on day 3 of each week, a load allowing them to perform 20 to 30 reps to failure each exercise set. Increases in elbow flexor, triceps brachii, and vastus lateralis thickness, measured by ultrasound, were statistically similar between both groups. That said, increases in elbow flexor and triceps brachii thickness do appear to favour the varied group. I managed to find an article by James Krieger, one of the authors of this study, exploring this more. Looking at the individual data for the triceps, there is one clear outlier in the varied group. After removing this outlier, the results still favour the varied group. Looking at the individual data for the biceps, after removing one outlier from the constant group, the results are pretty similar. Looking at the individual data for the vastus lateralis, the results are similar. So, except for the triceps, the varied and constant group experienced similar gains. It seems likely that the tricep results were a result of random variation, as it was not statistically significant. Remember, there were only 19 trained subjects in this study. Differences in genetics and degree of training experience could explain these findings. As a result, this paper overall suggests using different rep ranges does not improve muscle growth. Moving on, De Souza and colleagues split 26 untrained men into a constant, linear, or daily undulating group. All groups trained the Smith machine squat and leg extension twice per week for 6 weeks. The constant group trained each exercise with 8 reps to failure. The linear group trained each exercise with 12 reps to failure for the first 4 weeks, and then 8 reps to failure for the last 2 weeks. The daily undulating group, for the first 4 weeks, used 12 reps to failure for each exercise on Monday, and 8 reps to failure on Thursday. For the last 2 weeks, they used 10 reps to failure for each exercise on Monday, and 6 reps to failure on Thursday. Increases in quadriceps cross-sectional area, measured by MRI, was similar between all 3 groups, further indicating using different rep ranges is not more effective than using a constant rep range. Fink and colleagues assigned each arm of 21 untrained men into a high load, light load, or mixed condition. All subjects trained the unilateral dumbbell biceps curl 3 times per week on non-consecutive days for 8 weeks. The high load condition involved 3 sets to failure with an 80% 1 rep max load every session and 2 minutes of rest between sets, resulting in around 7 to 3 reps per set. The light load condition involved 3 sets to failure with a 30% 1 rep max load every session and 2 minutes of rest between sets, resulting in around 40 to 10 reps per set. The mixed condition throughout the 8 weeks alternated between 2 weeks of training with a high load condition and then 2 weeks of training with a light load condition. Increases in elbow flexor cross-sectional area, measured by MRI, were similar between all 3 conditions, again suggesting using different rep ranges / loads does not improve muscle growth. There are a few other studies comparing the use of different rep ranges to using a constant rep range. However, the issue with these studies is they used body composition or circumference measurements. These measurements are less sensitive and accurate compared to using MRI or ultrasound. Remember, the 3 studies we just looked at used MRI or ultrasound. Having said that, the majority of these studies still found no difference in body composition or circumference measurements between using different rep ranges or using a constant rep range. Adding further support to the idea using different rep ranges does not improve muscle growth, but 2 studies did observe improved body composition or circumference size when using different rep ranges. Interestingly, one of the studies by Kramer and colleagues lasted 9 months. They split 27 untrained women into either a constant or varied group. Both groups trained 3 times per week for 9 months. The constant group performed 8 to 10 reps to failure for all exercises. The varied group performed 4 to 6 reps to failure for each exercise on day 1 of each week, 8 to 10 reps to failure on day 2 of each week, and 12 to 15 reps to failure on day 3 of each week. Increases in fat-free mass, measured by skin fold calipers, were significantly greater for the varied group. Again, This measurement is not as sensitive or reliable compared to MRI or ultrasound measurements, so we should approach this with some caution. But if the varied group did truly experience greater muscle growth, I think there are two potential takeaways. The subjects were women. All of the other studies assessed in this video were conducted on men. Perhaps using different rep ranges improves muscle growth for women, but not men. More research would be needed to figure this out. Secondly, this study lasted 9 months. All of the other studies assessed in this video lasted 12 weeks or less. In the short term, there could be no difference between using different rep ranges or a constant rep range. But in the longer term, maybe using different rep ranges ultimately causes more muscle growth. This is an interesting idea. Maybe using a constant rep range every session in the long term has some sort of desensitizing effect, meaning the use of different rep ranges could be superior for avoiding this problem. However, this is just a hypothesis. Given we don't have any other research lasting many months, it's difficult to say. Hopefully future research adds to this area. To conclude, the current evidence leans towards the idea that both higher and lower reps produce similar slow and fast twitch muscle fiber hypertrophy, indicating using different rep ranges would not be advantageous in this aspect. Moreover, the overall current research suggests that in the short term, using different rep ranges does not improve muscle growth compared to using a constant rep range. It remains possible that in the long term, using different rep ranges could improve muscle growth. Practically, no research has found using different rep ranges to be inferior to using a constant rep range, so using different rep ranges is perfectly fine. For some, this could make training less monotonous and more enjoyable, and as discussed, maybe using different rep ranges in the longer term is superior, but future research is needed. If any more research comes out, I do plan to make updated videos.